Hey guys, welcome back. Here we are at section 1.6. We have made it to the end of our summer AP Calculus review, and focus of section 1.6 is trigonometric functions. So here are the things we're going to talk about, our learning goals. The first one, we're going to convert between radians and degrees. Then we're going to talk about arc length. We're going to identify periodicity and even and odd properties of our trig functions. We're going to sketch the graph of trig functions, and we're going to use transformations of our trig functions, and we're going to use some of the inverse properties of trig functions. Okay, so let's get started converting between radians and degrees. Okay, so first, if we start with degrees and we want to go to radians, this is how we convert those. To get radians, we take our degrees, we multiply by pi, and then we divide by 180. If we're going to go the other direction, if we know radians and we want to convert to degrees, what we're going to do to get our degrees is we're going to take the radians, we're going to multiply by 180, and we're going to divide by pi. So you can see that the two factors here are the reciprocals of one another. So we're always either going to be multiplying by pi and dividing by 180, or multiplying by 180 and dividing by pi. And if you can't remember which is which, take a moment and think about it. So for example, if we're getting from degrees to radians, the degree measurement is always a larger number than the radian measurement. So if I need to get from something that's larger to something that's smaller, it would make sense that the number I divide by is the 180, and the number I multiply by is the pi. So think about, do I need to make this larger or do I need to make it smaller? If you need to make it larger, you want to multiply by the 180 and then divide by the pi. If you need to make it smaller, you're going to divide by the 180 and multiply by the pi. So if you just think about what you're doing, it shouldn't come down to memorization, but rather it should come down to making a good decision and thinking through your process. Okay, next we're going to talk about arc length. So what we have here is, in blue in the middle we have a unit circle of radius 1. In green on the outside we have some random circle of radius r. So arc length, if you remember, the length of an arc is the central angle times the radius of the circle. So when we have a unit circle, the radius is simply a scale factor for that circle. So the arc length is going to be the radius times the central angle. So here's an example of this. This is example 1 on page 46 of your textbook. If we know that the radius of the circle is 3 and the central angle is 2 pi over 3, to find the arc length, we're just going to follow this formula. We're going to multiply the radius of 3 times the central angle of 2/3. So 3 times 2/3 is going to give us an arc length of 2 pi. Okay, here we go. These are the the basics of the 6 trig ratios. So we have a graph of each, of sine, of cosine, of tangent, and then of their reciprocals, cosecant, secant, and cotangent. And the information contained on this page is simply the basic stuff: the domain, the range, the period. So if you do not have this stuff sort of memorized, I'm going to ask that you pause the video here, jot this information down, and start to familiarize yourself with it so that by recall you'll know, okay, domain of a sine function is negative infinity to infinity, range is negative 1 to 1, and period is 2 pi. So go ahead and pause the video, take a couple of minutes and jot this information down so that you have it handy and you can refer to it when you need to. And then as we continuously refer to it, I'm hoping that you begin to memorize this and you can just get that by recall. So go ahead, copy that down, and I'll meet you back here in a minute. Okay, now that you have that information down, let's talk about which of these trig functions would be even and which would be odd. Okay, and to do that, we're going to think about the symmetry. Even functions are symmetric about the y-axis, and odd functions are symmetric about the origin. So I think it's probably easier to spot the even function. Symmetric about the y-axis means that the right side and the left side are mirrors of each other. So this one is not going to be even. This is going to be odd because we're symmetric about the origin. We're not symmetric about the y-axis. Same thing here. We are not symmetric about the y-axis. If we were symmetric about the y-axis, this portion of the graph would be up here. So this is going to be odd, and so is cosecant. Let's look at cosine. Right half of the graph, mirror image of the left half of the graph. So this one is symmetric about the y-axis. So cosine and then its reciprocal secant, those are going to be our even functions. And then tangent, let's see, here's the right half. Do not get that mirror image on the left half, rather I get it inverted on the left half, which means that this would be an odd function, symmetric about the origin. So tangent and its reciprocal cotangent are going to be odd, just like sine and the reciprocal of sine, the cosecant. So cosecant and secant are even, and then the rest, sine, cosecant, tangent, and cotangent, are going to be odd. Okay, finding trig values. When are trig values positive? This should look familiar to you. I know you worked with this in pre-calc, and we have a mnemonic that kind of helps us remember where things are positive, and you might have a different mnemonic device in your head. The one I particularly like is that ambitious students take calculus, and that of course means that in quadrant 1 all of the trig ratios are positive. In quadrant 2 for the S, the positive trig ratio is the sine and then its reciprocal, the cosecant. In quadrant 3 for the T, the tangent is positive, as is its reciprocal, the cotangent. And then down there in quadrant 4, the C, positive is the cosine and its reciprocal, the secant. So ambitious students take calculus. And if you don't happen to be particularly fond of ambitious and you want a different A adjective, this link right here, adjectivesthatstart.com, and then with A, it's going to give you a long list of adjectives that start with A. It's worth taking a look at. It's kind of funny. Maybe we'll have a little contest and see who can come up with the best adjective to put in front of this to describe what kind of students take calculus. Okay, we're going to put this to use here. Example 3 on page 48 says find all of the trig values of theta if the sine of theta is -3/5 and then the tangent of theta is less than 0. So we need to find out where is sine of theta -3/5 and also tangent of theta being negative. Okay, so first thing, our sine is negative. Well, everything is positive in quadrant 1 and sine is positive in quadrant 2, so it's not going to work in 1 or 2. Down here, sine would be negative. We could have a sine of -3/5 here in quadrant 3, but we also have the second condition that tangent has to be negative. In quadrant 3 is where tangent is positive. So quadrant 4 is the location where we're going to get both sine and tangent to be negative. And here's a graph of the right triangle that would generate a sine of -3/5. And you can see right here we have the question mark. So trivia question, the question mark should be equal to how much? And of course it has to be 4. This is going to be a 3, 4, 5 triangle. Okay, so what we're going to do is we're going to fill in this table and we're going to write down all of these trig ratios. Okay, so sine of theta. I'm going to grab my pen here. So obviously we know sine is -3/5. That was part of our requirement. So in there, let's fill in -3/5. And I'm trying to write with my mouse here. So I apologize. I know these are not going to be super neat. I'm doing the best I can. This is easier said than done. So go ahead and make fun if you'd like, but it's a little harder than it looks. Okay, so if sine is negative 3/5, that means cosecant is the reciprocal, so that's going to be negative 5/3. Okay, next, cosine. Well, cosine is adjacent over hypotenuse, so that's going to be 4/5. So cosine theta is 4/5. And secant, reciprocal of cosine, so 5/4. Alright, and tangent. Tangent is opposite over adjacent. So negative 3/4, negative 3/4. And cotangent, reciprocal, so negative 4/3. Okay, and here I have actually it typed out for you if you are having some difficulty reading my chicken scratching there. There's just a copy of the table above. Okay, second part of the question says, what if tangent is greater than 0? Okay, well, we already talked about that these are the two places where sine can be less than 0. So tangent is going to be greater than 0 over here. This is where tangent is positive. So that means we could draw in our right triangle over here in quadrant 3, and we're going to get the trig ratios from here. So now our question mark, instead of being 4, the length here of this leg is going to be negative 4. The length of this leg is going to remain negative 3. Not drawn to scale, disclaimer. And then again, we're going to get our hypotenuse to stay to be 5. Okay, so we are going to find all of those trig ratios. Okay, so the sine, still negative 3/5, because that's part of the requirement of this problem. And then cosecant, negative the 5/3, just reciprocal of our sine. Okay, next cosine. Well, adjacent over hypotenuse, so negative 4/5. Negative 4/5 would be our cosine. And reciprocal of that for the secant, negative 5/4. And then lastly, tangent. Tangent being opposite over adjacent. So negative 3 over negative 4. Tangent ratio is going to be 3/4. And cotangent then, it's reciprocal 4/3. Okay, so that's just finding our trig ratios, given some specific information, knowing when and where our trig ratios are positive.